multiple services. So this is not one of them. Here's this one. So you can see that this SVC host, in fact, is hosting 5 different services, but this is an exception, not the norm. Some of these services are critical to Windows, such as the DKOM launch service. You can see you can't even stop it or do anything with it. This is in fact the service that is responsible for many of the operations within Windows, such as, for instance, launching UWP applications, but it has other uses. And so this is kind of special, but most processes are going to host their own service. Now you might be thinking 3.5 gigabytes, that doesn't seem to be too much. I mean, which system doesn't have that kind of memory? So this is mostly about small systems, such as IoT devices, HoloLens, things like that, where the amount of RAM is not necessarily 3.5 gigabytes or more. So if the amount of RAM is smaller, then a different grouping is done, just like the classic way Windows worked before Windows 10 version 17.03. So next we have this color, which is a fuchsia color. It's not shown by default, but you can make it appear. And this is about protected processes. So protected processes is something we'll discuss in the next course in the series, but essentially you can't open a powerful handle, an invasive handle to a protected process. And this is important to make sure that these processes cannot be invaded, and most of them cannot be terminated either. So these are protected processes. In fact, you can right-click, select column, and there's a column here called protection that shows you the type of protection for these kinds of processes. You can even sort by protection. There's another color which appears from time to time. You might have noticed it while I was demonstrating stuff here, which is the green and the red colors. These colors represent new processes and destroyed processes. In fact, it's not just about processes. There are other views in Process Explorer where the colors green and red are used to indicate new objects coming to life and objects being destroyed. So for example, if I go ahead and run CMD here, you'll notice we get here CMD and conhost.exe being shown in green for a few seconds. If I go ahead and decide to destroy this process, the stored console window, both of them become red and go away. The amount of time these green and red colors are shown is by default 1 second. If you want some more, you can go to Options, configure difference highlighting duration here, and select something bigger, such as 4 seconds, as I've done here, in order for me to be able to see better or notice these green and red colors once they appear. So you'll see that in other windows in Process Explorer. Another thing I want to show you is that Process Explorer has these tree-like views. What is that exactly does that mean? And so the idea here is that the tree shows us which process created which process. So for instance, if I go ahead and double click on this process, we can see here in the image tab that this process was created by the MS Team teams.exe process with the process ID 3580. Which is exactly the process ID we see here as the parent for this process. The important thing to note here is that in Windows, processes are not really dependent on one another in that sense. So if process A creates process B, they're completely independent. If process A dies, process B is completely unaffected. So it's better to think about processes in Windows as siblings rather than having some kind of dependency of a parent-child relationship. So some of these processes seems to be kind of weird because they're all the way left justified, such as Explorer here. What does that mean? It means the parent of that process is no longer alive. So if I double click Explorer, you can see here we see the parent is shown as non-existent process with the process ID 2412, which means that the process ID of the creator or the parent process is stored in the data structure of the child process. But that's the only piece of information that is stored there. So we know the process ID of that parent, whoever that was 2412, but we don't have any other details about it. It is non-existent. So for non-existent process, Process Explorer shoves the process node all the way to the left, simply left justifies it. It doesn't try to find the grandparent of the process or anything as complex as that. Now, one thing to note is that the process ID might be reused. So maybe there will be a new process that has an ID which is equal to 2412. Does that mean that I might see here some incorrect process? So unfortunately not. Process Explorer is actually smart and checks to see the start time of a process that claims to be the parent. If the process exists and it was created after the current process, then of course it can't be a parent. It's just is that the ID was reused by a new process. And so Process Explorer doesn't get confused, and that's of course very nice. By the way, if you're worried about Explorer and thinking, well, poor Explorer, it's an orphan, it's probably not such a nice feeling and so on, don't worry about it, it's actually perfectly normal. Explorer is created by a process running an executable called userinit that does some work when by default a user logs in, and once it's done with its work, it simply terminates. So it's actually fairly normal to find Explorer to be parentless. So you shouldn't really worry about Explorer. But any one of the other processes you see here that are left justified means that their parent is no longer alive. So sometimes it is interesting to see which process created which process, but you should always remember there is really no dependency between processes regardless of which process created which other process. The last thing I want to show you about Process Explorer at this point is that it has a split view here that has a lower pane. And that lower pane can show two pieces of information. One of them is a list of DLLs or modules in the process. As you can see here, list of DLLs that are loaded into the process that I've selected at the top view. In this case, that would be an Explorer executable here. And we can switch the view using this button called View Handles and switch the view to handles in the process. So you can see all the handles in the process. Remember that Task Manager has shown us the number of handles in every process, but here you can see the actual details, each handle pointing to which object. Now by default, you will only see two columns. You will see the name column and the type column only. It will look something like this. So if you want to see more details, you have to right-click, select columns, and add more columns, such as the handle value, the access mask, which means what's the power of this handle compared to other handles pointing to this object, the object address, and the decoded access mask in a textual way. So we'll discuss some of these columns later on in this course. And by the way, by default, you only see objects or handles to objects that have names. This is what you'll see by default. You can see here I'm sorting, and you can see objects that have some kind of name here. If you really want to see the entire set of handles in the process, you actually have to check this option, Show Unnamed Handles and Mappings, which I had checked previously. So if I check that now, you can see the list of handles grows, and you can see that some of these handles are just pointing to objects that simply don't have names. The fact that the object doesn't have name doesn't detract anything from the object's capabilities. It simply means that you can't find or locate the object using that name. So we'll cover more details about these columns later on in the course, but I wanted to show you the ability to see the handles in a process and the modules in a process of your choosing by performing a switching here using this button. Just as an aside, look at the protected processes, you get absolutely nothing in terms of DLLs. This is one of the limitations in Process Explorer right now, but I've actually enhanced Process Explorer. I was part of the sysinternals team for a little while, and the next version of Process Explorer will allow you to see that fully. And I'll explain why we can see that later on in this course. The really last feature I want to show you in Process Explorer is by pressing Ctrl-Shift-F, you can perform a search. And this allows you to search for any object with a name. For example, you're probably familiar with the case where you're trying to delete a file and it fails to delete because some process is holding onto it. And you might wonder which process is holding on to that file. And so you can use this dialog to search for that file, figure out which process is holding it, and then perhaps terminate that process, and that handle will be closed to that object and you'll be able to delete that file. So I can do anything I want here. I can type a part of a name of something and we'll get everything that this name provides, such as file names, object names, such as processes, threads, and other stuff depending on what we're searching for. Every time we click something like this, one of these entries, Process Explorer jumps to the appropriate handle where it located that particular instance where that name was available. So this is Process Explorer. We'll see more features of Process Explorer later on once we start looking at other concepts such as threads.